day to you all. Today we'll be discussing variation of parameter. Continue from there and look at the applications. Then if you have any question on that, then we can also attend to that. So when it comes to variation of parameters, I will not give us too much details. You can see your textbook and also look into some of those key things you need to check there. And the major thing I will look into, I will give us some of the steps. There are steps here in your course material, but you might not really, get some of those details, but let's look at it together. Look at this model. They said L variation of parameters. Let me just write this model out. It says Ly is equals to y prime prime plus a1 of x y prime plus, let me just write it here, plus a2 of x y, everything equals to b of x. Now, this is the model you're supposed to follow when you are working on this variation of parameters. In some questions, they will ask you to use variation of parameters to solve them. If it is you are doing paperwork, the lecturer can ask you to use variation of parameters to solve it. Are you getting it now? It simply means you need to follow a certain pattern of solving the problems. But in this case now, what we need to do is just to follow what we have. Let's look at the steps. Step 1. The steps. Number 1, you need to do is you must put your equation in standard form. This is the standard form. Equation 1 here is the standard form. So put the equation. When I say equation now, in this case, I'm talking about the problem you're given to solve. So put equation in standard form. Standard form. That is, let's look at the example. If I have 4y, or let's say I have 3y prime prime plus y prime plus y equals to cos 2y, or equals to, let's say, cos x. So it simply means I need to change this. You need to transform it to what? Who can tell us how to do it in order to make it equation 1? Yes, anybody? So what you need to do is just to divide both sides by 3. Divide both sides by 3. When I divide both sides by 3, what do I have? Remember here, this y prime prime must stand alone. The y prime also can have a coefficient, y also can have a coefficient, and so on. So I will divide both sides by 3. So I will divide both sides by 3, by 3, by 3, each of them by 3. So it simply means that for us to have a standard form, I'm going to have y prime prime plus 1 all over 3 y prime plus 1 all over 3y equals to 1 all over 3 cos 2x. So this, in this case now, you can now begin to solve because your equation is already in standard form. Any question? Are we together? Are you? Can you hear me?
Yes, sir.
Okay, good. Okay, let's look at this step 2. That's step 1. Step 2, solve the associated homogeneous equation. That is, solve the associated homogeneous equation to get your y complementary. You remember y complementary from the last class? C1 y prime y plus C2 y2. Do you still remember this?
Yes, sir.
Okay. So that is, if you are given this, the problem here will be what? If I want to translate this one, how do you translate it? The first, this particular example I gave in step 1. How do I translate this? I will have it to be what? M squared. You remember? Plus what?
Plus 1 over 3m.
Check your notes. Check your notes. Ibrahim, are you there?
Yes, sir. I'm there.
Philip.
I think you M squared plus 1 over 3m.
Plus 1 over 3m plus
Okay.
Plus 1 over 3.
Plus 1 over 3, yes.
It's going to be what? 1 over 3m.
Plus 1 over 3 alone.
Plus 1 over 3 equals to what?
A cos 2s.
Really?
Now 1 over 3 will be outside the bracket. 1 over 3 will be outside the bracket. Then we're going to have a cos 2s plus b sine 2s.
Equals to 0, Mr. Mathematician.
Sorry, we are doing the homogeneous. I'm sorry. I thought we were doing the...
No. We are doing homogeneous, not non-homogeneous.
Yes,
we are doing homogeneous now. So it will be equals to 0. Once it's homogeneous, it will be equals to 0. Then you can solve it. After you solve it, you have the 2m. When you have the m, then from then you can now go ahead and check it. Let's look at this one. We are still in the same condition here, but there's something. There's this mathematician called Rokitian. So we are using the Rokitian method. You can see it's there in your book, but only that the typing was not that okay. We are still using the same thing, but I want to make it simpler so that if we are using this Rokitian steps, how does Rokitian say? What the Rokitian law says? What are the things we need to do using Rokitian 1? So let's look at it. I hope you are following now. I've not solved anything. I'm just trying to lay the foundation, giving us how we can go about it. Okay, let's look at number 3. Number 3 says compute Roskian compute the Roskian. The Roskian says what? 2 things. Number 1, you need to do is W equals to Y1, Y2, then Y prime of 1, you differentiate it, then Y prime of 2. Then while you are doing this, the next thing is you need to do is find W1. The W1 means make the first entry 0. You have your y2 here, then f of x. You remember your equation, your general equation equals to, we call it b of x here, it's still the same thing as f of x. Probably I should change this one to f of x so that you understand what I'm saying. It's still the same thing as f of x. So you substitute it with f of x. Anything that is the other side is f of x. So you substitute it f of x. We call it y prime of 2. Are you getting it? Then remember that you put f of x where you're supposed to have y prime. So, and you have this, y2 will be equals to y1, 0. You take the other side to be 0, and the y prime of 1 and f of x will now take place here. So that's how you compute. Don't forget that this particular law that I'm using is the same law as the theorem of determinant. That is, you cross multiply here, you multiply both of them, then you have your answer. So now let's move on. Step 4. Compute your u1 to be equals to integral of w1 over w dx, u2 to be equals to integral of w2 over w dx. Everything will different. We integrate everything to be x. Then number 5, you find your y particular, which is u1 y1 plus u2 y2. So in this case now, it makes it more simple for us to do. I can take us to our material also. You will see something similar. If you look at equation 14, they are still trying to do the same thing. Equation 13, equation 14, they're trying to do the same thing. That's how they put the steps. In case you are reading your book, you can also relate to it. But in mathematics, the beauty of mathematics is you can have different opportunity to solve different problems using different methods. You can see by the time we finish with this method that I put together now, you will discover that some of the things that are not clear in your books, you will have an idea, better understanding about it. Let's move on. Let's look at the example. Example 1. Example 1. So we have y prime prime plus 3y prime plus 2y equals to 1 all over 7 plus exponential x. 1 all over 7 exponential x. So in this case now, how do I know that I need to use this method? When you have second derivative, like this question also can come in this form. You have to be smart about it. The square y, the s squared, plus 3 dy dx plus 2y. It's still the same thing. All we need to do is just to be carried along that, oh, we are still talking about second derivative. So now let's move on. What is the step 1 now? We need to follow. Somebody should read step 1 for us.
Put the equation in standard form.
Put the equation in standard form. put the equation in standard form. So that the first thing I will ask you is this equation in standard form or not?
It's in standard form.
It's in standard form, correct. Then you've done the step one. Step one now, put the equation in standard form. Y prime prime plus 3y prime plus 2y equals to 1 all over 7 plus ex. Now, step two. What is step two?
Solve the associated homogeneous equation.
Now, how do we write homogeneous in this case? M squared plus 3m plus what? Hello? Plus what?
2.
Plus
Plus
2 equals to 0. So can you get your m for me? Let me have your m. Our m, who is
m plus 1, m plus 2. That should be
m plus 1 and m plus 2 equals to 0. M plus 1 equals to 0 or m plus 2 equals to 0. Then m is equals to minus 1 or m is equals to minus 2. Then what is your y complementary will be? Anybody? Can you write it up? Tell me offhand and I'll put it down. It's there. You can see. C1 is what? Exponential what now?
Minus x.
Exponential minus x, because you have m1 to be minus 1. That is, one of the m is minus 1. The second m is minus 2. Then the second one will be C2 what?
Exponential minus 2x.
Minus 2x. That's all. That's what they asked you to do. So now, you need to identify. Remember, from step 2, we said our y complement is C1 y1 plus C2 y2. Then what is y1? Let's identify it. Anybody?
Minus x.
Is what?
Exponential minus x.
Exponential minus x. Then what is y2?
Exponential minus 2x.
Good. Then we can proceed and differentiate. So let's differentiate this one. Y prime 1 is what? When you differentiate exponential minus x, what do you have? Bisola, what do you have?
So what do you want to differentiate? When we
Differentiate the y prime, y1.
That would be minus
minus
x,
minus
x.
It's very simple. Let me just give you simple method. This means d dx of what? Minus x exponential minus x. That's what they ask you to do. And you and I know when you differentiate x, you have 1. And is negative x, you have negative x. You have negative 1. So, and you don't write 1 in mathematics. You just put it this way, minus exponential minus x. So when you now differentiate y prime 2 is what?
Minus 2 exponential minus 2x.
Minus 2
Exponential
minus 2x. Simple. Okay. Now, the next step is what? Step 3 is what, please? I need someone to talk.
The fractions.
Yes, step 3.
Compute the Roskian.
Compute the Roskian. Okay. Now we know that we have W. What is for Roskian? What is the? We need Y1 and Y2. What is Y1, please? Somebody should tell us. Is there in your notes?
Minus x.
exponential minus x.
Exponential minus x. What is Y2?
Exponential minus 2x.
Good. Then what is y prime y1 prime
Minus exponential minus x.
exponential minus exponential minus s. Then this one will be minus 2 exponential minus 2x. Let me write it very well. So now, how do we solve this one? You remember the way we do it in matrices. This will multiply this, right? So we have it to be, and this one will also multiply this. This is A, this is B. You remember? So A will go and multiply this. We have minus 2 exponential what? Anybody?
Exponential minus 2.
Exponential what?
I'm only calling the question.
Exponential minus x.
No.
Minus 2 plus
Yeah, that's the minus 4x. Sorry.
Exponential.
minus 3x.
That'll be exponential
3x.
minus 4x.
Wait,
1.
minus 2x in bracket exponential minus x, right?
Yes,
Yes, sir.
sir.
Minus, don't worry, I will teach you a lesson today. You will see. Exponential minus 2x in brackets. In bracket what?
Exponential minus x
Minus
Exponential.
x.
Minus times minus plus.
plus.
Are you getting it now? So what you need
Yes,
to do,
sir.
remember this a raised to power n multiplied by a raised to power m is the same thing as a raised to power n plus m. Do you agree with me?
Yes, sir.
The same
Yes,
thing
sir.
will happen to this power. It's not multiplication. You remember multiplication, bracket means multiplication. Am I right?
Yes, sir.
Sir.
Then if bracket means multiplication, what do we have?
That's minus 2 exponential minus 3x.
Correct. Correct. So you have minus 2, you see the lesson now, exponential minus 3x. That is, you only had the power, the base are the same, which is logarithm. Am I communicating now?
Yes, sir.
Who is not clear to? Okay. Silence means we are all okay. Okay, let's write. This one will be what? Exponential minus 3x. So this minus this, what do you have? This minus this.
Minus e
Minus x.
minus exponential minus 3s.
Thank you. So that is our W. Now let's look at W1. W1 is what? So we have in W1, the first one is 0. The second one is Y2, which is exponential minus 2x. And the f of s, okay, probably I should write the formula again.
Yes, sir.
Yeah?
Yeah, you can write again, sir.
Y what? Y2. Excuse me. F of x and y prime of 2. So which is the same thing as 0. What is Y2?
Exponential minus 2x.
F of s is what? From that question. Then y prime y2 of prime, or y prime of 2, or what do you call it? So let's call minus 2 exponential minus 2x. Do you get it now? So this is what I'm saying here. if you look at this, your y, your f of x is equal to y all over 7 plus ex. Just a minute, please. Okay, are we there now?
Yes, sir.
Okay. So can we solve the equation 2 by ourselves? Can we solve? Can I have one? Can you solve this
With
one?
W2. Yeah,
W1 is what? Anybody?
that would be
Exponential
exponential.
minus 3 over
You
7
do
Yes,
plus
0
yes.
multiplied by
That'll be 0.
It's zero. Still zero.
is 0 minus 2 exponential minus 2x minus exponential minus 2x in bracket 1 all over 7 plus exponential x. So what is y1? W1?
Zero.
Negative exponential minus 2x. Do you agree? Divided by 7 plus exponential x. So what is y2 now? W2 rather. W2 is what? The formula say y1, 0, y prime 1, y prime 2. And the second one is what? F of x. The same thing as, what is y1? It's there in your notes.
exponential minus x.
Then f of x, yes? Any question?
7 plus exponential x.
So when you cross multiply, also you have y2 to be what? E raised to power minus x divided by 7 plus ex. Everything is minus 0, right? Minus 0. So you don't need that. So now that we have this one. Then we have this one. So what is the next thing to calculate is our u. Our u1 says integral of w1 over w dx, which is same thing as integral of minus exponential minus 2x divided by, that's w1 now, 7 plus exponential x, multiplied by, it's supposed to be divided by again, right? Are we together?
Yes, sir. Yes, sir.
Remember, what is W1? W1 is this one. Then what is W itself? W is what? Minus exponential minus 3.
Minus 3.
Remember, it's supposed to be divided. Okay, let
Yes,
me just
sir.
divide it. Divided by minus exponential minus 3. Everything dx. So you can now begin to change it. Our u1 will be integral of minus exponential minus 2x over 7 plus exponential x divided by, what's the reciprocal of this one?
That's 1 over e minus e exponential minus 3.
There's going to be, they just change it, remove the minus. That's the power.
The power, yes, but for the purpose of some of us that we are still learning, how do we do that? You don't need to even remember that it's negative. The negative, we cancel negative here. But let's just leave it this way first. Right?
Sir.
Do you agree with this?
Yes, sir.
Yes, sir.
This one cancel this. Now, how do we now solve it? Look at it critically. You have, if I change the power now, like Ibrahim suggested, which we are going to do, we are going to have integral of exponential minus 2x over 7 plus x dot exponential 3x, right? dx. So you agree with me that the power here we go, right? This
Yes,
will
sir.
go, remain x here. Because when you add it together, you will remain x. So you have u1 to be equals to integral of exponential x over 7 plus exponential x dx. Now, how do you integrate something like this? I need a good idea. Somebody would. How do you integrate this? Let's u equals to 7 plus. You remember this method?
Yes, sir.
The u, the s is equals to what? Differentiate this now. The u, the s is equals to
That'll
what?
be exponential x.
Thank you.
Exponential
Equals to
x.
exponential x. Because remember, 7 will have turned to 0.
0 is a constant.
Yes. By the time you cross multiply, the u will be equals to exponential x dx. So how do I solve it? So what is the answer? Yes?
Since we have the u, and if we replace it with e exponential the exponential x dx, that will, let me try and write it down first.
Better. Do we need the u or the x we need to find?
Is this what we're looking for?
Is the s. So what's the s now?
Yes, will be the u over exponential x.
Yes. So we can substitute now by saying our u1 is equal to integral of exponential x over u dot du exponential x, right?
Yes, sir.
This cancel this. So you have it to be u1 equals to integral of 1 over u du. So what's the answer of 1 over u du?
Ln u.
Ln u. And what is your u? Ln what? Do you agree with me?
Yes, sir.
That is equals to u1. Who is not clear to? Raise up your hand in case you have any question. Can we proceed? Okay. Silence means proceed. Okay. Let's look at the u2. You have u2 divided by u, the x, which implies integral of what is u2? Exponential minus x over 7 plus x exponential x dot negative 1 all over exponential. Exponential what?
Exponential minus 3x.
Minus 3x.
Yes, sir.
So the s. By the time you change everything, what do you have? We'll do the same thing with the way we did it the other time. Let's change the narrative. Can we go ahead? We have it
Yes,
to
sir.
be exponential. We have negative. We can take negative out. Are we together, please?
Yes, sir.
Let's say the negative is here, exponential minus x divided by 7 plus exponential s dot exponential 3x dx. So which is the same thing as, that's u2. Which is the same thing as minus integral exponential 2s over 7 plus exponential x dx. So can we solve this one?
Okay, once solve this, sir.
Yes, solve it and let me know the answer.
All right, sir.
Are we there now? The issue is, if you are trying to solve this, there are certain problems you will encounter. I don't know whether you noticed that.
Yeah, it didn't cancel out in this case.
They will not cancel out. Yes. So who can tell us what to do if they didn't cancel out? Now, one of the way we normally do something like this is, don't forget the negative. Now, I can work on this. Okay, do you remember this law? This way of solving it, x over x plus 2. If I want to solve this one, I want to break it down, I want to simplify it, I can say s plus 2 over s plus 2 minus 2 over s plus 2. Is it possible? Is it possible? It's a kind of simplification that we normally use in complex number. So this one will go with this. And at the end of the day, I will have it to be 1 minus 2 into s plus 2. So we use this method, the way of solving this one. So when you use it, how do we now solve them? Okay, if you find the LCM of this, am I still going to have this one back? Are we there?
Yes, sir, but I'm lost.
I don't get this, sir.
Okay,
So,
if I find the LCM of this one in brackets, am I going to have this back? Let's see, s plus 2, right? How many s plus 2 is there? Is 1. We have
1.
s plus 2 minus, this is 1, right? 1 multiplied by 2.
Yes, it is.
1 multiplied, this is 1. 1 multiplied by 2, I will have what? 2. So at the end of the day, I will have this one will go with this. I will still have s minus s plus 2. That is what we are trying to get. I'm just trying to show us that I can still get x over s plus 2 back using this method. Are we together now?
No, sir.
Okay, let me explain again. How do I explain? Remember, we need to break it down for us to integrate. We are not integrating yet.
Yes, sir.
I hope all of us can. Are we on the same page?
Yes, sir. We're not integrating.
Let me explain. Now, we cannot break this one down because they are not canceling out the way this one did. You see, if this one is easy for us, we can easily call this one lean something, because you can see this particular one, this one cancel out. That is why. If we have 2 here, you will not cancel out 2. Do you agree with me?
Yes, sir.
How do we now break this one down? How do we simplify this one? How? How do we simplify it? I now gave us an example. I said, okay, listen, you agree with this one. When you have x over s, I'm just using this one as illustration, s over s plus 2. Are you getting it? Now that I have x over s plus 2, I want to simplify it. I can have the same thing by saying x plus 2 over s plus 2 minus 2 over s plus 2. The question is, will I still get, if I solve this one, will I still have this one back? The truth is yes. Now, this one cancel this, right? I have 1 minus 2 over s plus 2. It simply means if I want to integrate now, I can easily integrate 1 and integrate this one. That is where I'm driving to. But now, let's see whether we can get this one back. If we can get it back, then we can adopt this method. Over 1. Let's find the SCM. SCM is s plus 1, s plus 2 rather. How many 1 is here? Is s plus 2. S plus 2 multiplied by everything. S plus 2.
Plus 2.
How many s plus 2 is in s plus 2? 1. 1 multiplied by 2 minus 2. Then it shows that I can have s plus 0 over s plus 2, which is the same thing as s over s plus 2. Then I'm still within the region of what I'm solving. Did you agree with me?
Okay, sir.
Now, I will now use this method to solve the above problem. Since I know I only need to integrate, I want to integrate.
Hello, sir.
Yes, go ahead.
Please, what should we call this method, by the way?
A simplification. It's more or less of simplifying your way out of the problem. When you are hooked, in this case, there's this particular topic we normally use. Is it that complex? I forgot now. That we normally use this method in order to make ourselves in order to make it easy for ourselves. And mathematically, you can see it is right. Yes or no?
Yes, correct, sir.
It's correct. So that's why we use them. So in case you are also hooked in this case, so this is the way out. You have another way out now. That's why. Now let's look at this. We want to break that. Let's just break it down first. Forget about the differentiation integration. Once you break it down, what you break down will be the one we are going to work on with. Are you getting it now?
Yes,
So
sir.
let's break it down. So we have E2x. Don't forget negative is outside. We're trying to break it down over 7 plus e raised to power 0, e raised to power x, right?
Yes, sir.
Now, how do we break this one down? You agree with me if I say I can split this e. I can say the e is the same thing as e raised to power s dot another e raised to power x. It will give me, what do you think it will give me? Do you agree with this?
Yeah, of course.
Okay. Now,
That we
since
might
you agree with since you agree with this, then let me now break it. This is what we want
What
to
about
do.
the minus?
No, you don't. No. Remember, minus is everything. I'm just using this analysis now. That I'm breaking it down for you the way I want to do it.
All right. Sir.
So when I break it, don't say, which one are you doing, sir? Now look at the minus is there. So I take one of the e out of this one, es, and I open the bracket. I will have es plus 7 divided by es divided by 7 plus es, right? Am I right?
Yes, sir.
Remember what we did here.
Yeah, the method you use.
S plus 2 and S plus 2 cut themselves. The only figure that will be here is the same 2. The only figure that will be here is what? Minus what? Somebody should talk, please. Do you agree? Do we agree?
So I'm still looking at it.
Now, go to the method I use now. This particular one also will cancel it. You get it? Then we have minus exponential x 1 minus 7 over 7 plus ex. Remember, I need to integrate now. I've not done the integration. So I can go ahead and now say, open the brackets now. I can say minus exponential, this multiplied by 1 plus 7 exponential x over 7 plus ex. So this is what I will substitute now to go and integrate. So any question? Silence means no question. Welcome to mathematics. So we move by saying now, we integrate now. It's going to be integral of minus exponential x dx plus integral of 7 exponential x over 7 plus ex dx. If you solve this one very well, using the same method we did the other time, you're going to have minus exponential x plus 7 ln equals to u2. Any question? Ask your question, please. Let's ask question. Are we still here?
Yes, sir.
Yes, sir.
Okay,
Oh, wow.
let's continue. Okay, where is not clear to you? Should I go over it again?
Yes, sir. Yes.
Okay, look at this. Do you believe in this analysis, this particular one? Do you believe in
I
it?
do. Yes, sir.
Good. Remember, we only play with this parameter, this value. Then we arrive at this. This is our solution. This is our solution initially. I just prove it further for you to see that you are still going to arrive at this again. That's what I did. Now, we now want to apply the same thing to this. I have exponential 2s here. I can break exponential 2s to be exponential s dot exponential s. It's still the same thing as exponential 2x. I break it down so that I can have the same thing. Because if this one is still exponential 2x, I will not be able to get exponential s here. That is why I break it down. Am I communicating now? And I said,
sir.
let me take exponential 2s out. You can put it in a small bracket. It's still the same thing. Now, by the time this one, 2 plus 3, 3 plus 2, is it not 5? Hello?
Sir.
When you have 2 plus 3 and 3
5.
plus 5, and 3 plus 2
5.
is what? 5 over
But they
5.
are both
So
5.
that is why it cut is. And when you cut this one, this is 7. This is 1. And remember from here, I only pick this material to this place, which is true. And the same thing I did. Because the one that contains x will still remain x. But the 7, the value will go up, divided by 7 over the same denominator. And that was what I did. I just multiplied the exponential that I took out the other time, and I put it here. And they are all here. And it is make it easy for me to now integrate. Am I communicating now?
Yes, sir.
Okay, thank you. So remember, we are still on one question. So we have our U1 and U2.
Hello, sir.
Yes, go ahead.
Even though I'm following the steps, but I can't even remember what we're doing exactly. What the question say we should do, sir?
Which one? You said you can't remember what?
What the question say we should do? I'm following all the steps.
Okay,
I
if
don't
you
know
are
what we're
following
doing.
the step, this particular one, we are just trying to step what now? If you are following the step, check the step we are in. This is the step that is very
Step 4.
Step 4, where you are getting U1 and U2.
And U2, yes. So we're going to step 5 now.
Now we are moving to step 5 now. Step 5 says what?
Find YP, Y particular.
YP equals U1 Y1 plus U2 Y2.
YP equals to U1 Y1 plus
U2 Y2.
U2 Y2. The rest is just combination. So what is U1? Check your notes.
U1 is lane 7 plus E is for S, that's E exponential S.
E exponential S. What is Y1?
Y1
is the
Exponential minus x.
negative exponential x. Okay, sorry. Exponential minus x.
Yes.
Y1 is exponential minus x.
Minus. So we have it to be plus. What is U2?
U2 is minus exponential s plus 7
lane 7 bracket 7 plus exponential x.
Is it okay by that?
Yeah, it is. It is.
What is Y2?
Exponential minus 6.
Y2 is exponential minus 2x.
Minus 2x.
Okay. So if you open the bracket, what do we have? Let's try and open the brackets one after the other. Exponential minus x ln 7 plus exponential x. So we can multiply now. So what do we have there? Plus what? Anybody?
We have about 3 brackets.
Yeah, plus 7 exponential minus 2x ln 7 plus exponential x minus, when you add the two power together, what do you have? Exponential minus x.
Minus
Do you
x.
agree? Do we all agree?
Yeah, we are using that minus 2x to open the
Yes.
bracket.
Yes, you are using this one to open this bracket. So when you know this particular one, they are just 1. This is also 1. So it simply means 7 will multiply this, is still everything multiply. Then this will multiply this. So this is our YP. Our YP is equals to this. Then finally, we need to get our Y. You remember general solution, the way we did the other time, is still the same. We have Y to be equals to YC plus YP.
YP.
So let's substitute. And you know our YC is what?
C1 x plus C2 exponential minus 2x.
Then plus everything here. So what do we have? Plus C exponential minus x ln. Don't try to add this together because they are not the same. Ln what, please? Somebody should read it for us.
Ln 7 plus exponential.
Ln
x.
7.
Yes. Plus
Yes.
exponential x plus 7 exponential minus 2x. Ln 7 plus exponential x minus e minus exponential minus x. Minus exponential minus x.
So is there anything that cuts that can go? Which one do you think we can match together?
That is ln 7 plus exponential x.
C1 plus what? C1 plus what? Anybody? You can match this one together.
7 plus
With this one, right? Do you agree?
yes, sir.
So if you match it together, what do we become? So that is C1 exponential minus x minus exponential f. So if you merge it together, it's fine. If you don't merge it together, there's no crime. But some people would like to merge it together, which is going to be C1 minus 1 exponential minus x. We can call this one C3 exponential minus x, just to reduce it. So if I call it C3 exponential, because constant is still constant, anytime, any day. So we can write it by saying y equals to C2 exponential minus plus C3 exponential minus x plus, you can write the final answer. That's your final answer. Any question? Is it interesting?
No, sir.
No. Okay. Let it be interesting. Yes, Bisola, you want to say something?
No, sir, I don't have anything to say, sir.
Please, my question is this. How do you think your people in different centers that are not, we will be able to be on the same page? I think it's fine. So let's move on. So let's look at the Newton law. Look at another question on that particular, on the variation of parameters, and solve them. Then go to your textbook. If you can merge it together, please do. How do we know? If you can practice this method very well, if you see any question on that, sincerely, you'll be able to solve it. So what does the Newton law says? The Newton law of cooling states that the time rate of change of the temperature of a body is proportional to the temperature difference between the body and its surrounding medium. The Newton law said, Newton's law of cooling states that the time rate of change of the temperature of a body is proportional to the temperature is proportional to the temperature difference between the body and its surrounding medium. When you using a Newton law of cooling, derive a different equation for cooling of hot body surrounded by a cool medium. So in this case now, we said let's just look at the way we derive it. Let T denote the temperature. I'll be using this as temperature of the body and let Tm subscript m denotes the temperature of the surrounding medium. You can see we use Tm for surrounding medium. That when you are talking about temperature, let T represent the temperature, which is T. If you are now changing, if you want to check the rate, it will now be the T, the capital T, the small t. So it denotes that. So then the time rate of change, of the temperature of the body is the capital T over the small t. Please take note. Then we can now formulate this particular law. Now we have a Newton law of cooling can be formulated as the capital T, the small t, equals to minus K over T, that is body temperature minus medium, or some people put it as what? The T over the small t plus KT equals to KTM. So it's still the same thing. Try to open, that is the medium. What is K? K is the positive constant of proportion that we are discussing. That is when you say proportionality, you remember the proportion, the way we normally solve the proportion, where K is a positive. You see, positive is a positive constant of proportionality. So since K is chosen as positive, the minus sign in Newton law is required to make the T, the capital T, the T, negative for a cooling process. Please take note of that. Note that in such a process, the T, which is temperature, the capital T, is greater than the T medium. Thus, it's T minus Tm. Like we said, that capital T is greater than this. Take note of that. Now let's look at the example.
Sorry, sir. Excuse me. What do you say the TM is again, sir?
Let's check the definition here.
Hello, sir.
I'm with you.
Okay.
is here. Tm denotes the temperature of the surrounding
Okay.
medium.
Okay.
Are you getting it now?
Yes, sir.
Who can tell us the medium? Who can tell us the medium, the body temperature? What is body temperature? The minimum body temperature we have is what?
36.9.
Okay. So that they now said body temperature must greater than the surrounding temperature. Are you getting the point now? That is, in your room, you get what I'm saying now. So let's continue. Let's look at the example. Wow. I need to rush now. A medium, let's write fast. Oh, okay, sorry. Let me use metal. A metal bar at a temperature of 100 degrees Fahrenheit is placed. I believe you know how to convert this one. If you don't know, go and check it.
Yes, sir.
To convert it to the Celsius in case they ask you to do that. In a room at a constant temperature of 0 degrees Fahrenheit, if after 20 minutes the temperature of the bar is 50 degrees Fahrenheit. Find an expression for the temperature find an expression for the temperature of the bar at any time. So we know the model. The model is here. We can call the model equation 1 or equation 2 or equation 3, depends on you how you want to call it. I can call this one, this is our model, right? Let's call this one equation 1. You can call this one equation 1 because I will be referring to that model. So solution now, how do we solve this? The surrounding medium is the room. The surrounding medium in this case is the room, which is being held at a constant temperature of 0 degrees Fahrenheit. So it simply means that our Tm, is equals to 0. Do you agree with me? I need a response, please.
Yes, sir.
Our Tm is equals to 0 because we already defined the Tm to be a surrounding, the temperature in the room or in the medium of a particular area you find yourself. Now, the model said dt, the capital T dt equals to K minus K into T plus minus Tm. And it becomes what? dt over the small t plus k capital T equals to 0. Do you agree with me?
Yes, sir.
Okay, good. This is a linear equation. So now, since we have a linear equation, how do we solve the linear problem? And it also has a differential form. How do you solve it? The first thing you need to do, yes, Ibrahim, go ahead.
So that you separate them. dt over dt equals to minus kt.
Now, we have it to be equals to minus kt, right? We need to use separable variable now. Let the t go to t, let other one goes to the other one. So using separable method, we divide through by what? Or we multiply through?
I'm sorry.
Yes.
Must we equate it to 0 as in the form of linear equation, or just start solving?
No, it's because of this question. Our TM is equal to 0.
Okay.
In another case, your TM might not be equal to 0. Do you agree with me now?
Yes.
Can we proceed now?
Yes, sir.
So multiply through what? By what? Anybody? Tell me, what do I need to use to separate them?
Should be the t.
Yes. Is that all?
The
t?
Okay.
The small t or the capital T? Don't let me give you the answer.
Small t. The small t.
Small t over what?
Over k. Over
no,
k.
over t.
No.
Okay.
Do you agree with me? It's over t.
Yeah, big T. Yes.
Aha. So let's do it. We have dt over capital T, the capital T over the t, equals to minus k t over small t over capital T. This one go with this. This one go with this. So we have 1 all over t, the capital T, equals to minus k dt. Any question?
Sir, I don't understand. Why did you use? I thought we were only going to multiply through by only dt, like by only.
If you multiply through by dt, k is not having, k has no business with t.
Okay, sir.
Instead of us to do it twice, I did it once. Wait, I know the issue. Let's go back. Let me follow you. Okay.
Okay, I get it. Just like you used to
wait now.
Two bed.
Yes. You said multiply through by dt. That is what you know, right?
Yes, sir.
Okay, the capital T over dt multiplied by dt equals to minus k t dt. This one go with this, remain t. Capital T equals to minus k t dt. So how do you solve it? Go ahead now.
Okay, so you now divide by capital.
Exactly. Because we still have element of t here, which has nothing to do with k. Because supposed to be here with capital T, supposed to go with capital T. Are you getting me?
Yes, sir.
So we now say divide through by capital T. Are we together now? When I divide through by capital T, what do I have? I will have dt over capital T equals to minus kt dt over capital T. This one go with this. So I have 1 all over t, the capital T equals to minus k dt. Then integrate both sides. What do you have? What do you have here?
Having T.
And here we have minus kt plus c. Do you agree with me? So take exponential of both sides. You have exponential in capital T equals to exponential minus kt dot, plus means dot, exponential c. So what do we have here? Our t is equals to exponential c is still c. We call it c exponential minus kt. That is equation 2. Now, let's go back to the question. They said, since T, capital T is equal to, what is the temperature now? 100, right?
Yes, sir.
Now, they said a metal bar at a temperature of 100 Fahrenheit. So, if it's 100, and at that point, small t is equal to 0. You remember? They said a metal bar at a temperature of 100 Fahrenheit is placed in a room at a constant temperature of 0 degree Fahrenheit. The temperature in a room is small t. Do you agree with me?
Yes, sir.
So we have it to be 100 is equals to, we are trying to get our c. C exponential minus k of 0. So you have 100 is equals to c into 1, because everything here, exponential 0 is 1. Therefore, our c is equals to 100. Then I can rewrite my equation 2. Equation 2 now become what? Equation 2 becomes what? Anybody?
T equal to 100 e raised by minus k.
Thank you.
C.
So we call this one equation 3. That the question is further. I said, if after 20 minutes, we are talking about t now, small t. If after 20 minutes, at small t equals to 20, we are given that capital T is equals to what? 50 Fahrenheit. Am I right?
Yes, 50 Fahrenheit.
Yes, sir.
They now said, find the expression for the temperature of the bar at any time. So we want to get what is K would look like. What is our K will look like? Our K will be what? Let's go ahead. So we said equation 3, 50 equals to 100 exponential minus, what is small? 20K. Do you agree with me?
Sir, the K.
Yes, sir.
The K is in minute. I will also leave it in minutes or seconds.
No, you not solve it. You are saying it's in the minute or seconds. Is it not when you solve? You know whether it's a minute or seconds.
He meant to say T.
Are you getting this point now?
We have not found K.
We have not found K. We are still looking for K.
Oh, okay, all right. I guess.
We are looking for K. Remember, from the question, what do they put their time? They are in minutes.
Time is in minutes.
So far it is in minutes. Assuming they call this one hour, then you'll be talking about hour. From the question, you will have idea of what they want to you are trying to do. So what do we do here? Somebody should help us.
Can divide both sides by 100
Right.
first.
Divide both sides by 100. So we have it to be 50 divided by 100 equals to 100 exponential minus 20k divided by 100. So this go with this. We have 1 over 2 equals to exponential minus 20k. Somebody must, how do we bring exponential down? The power on exponential. You take the ln of both sides.
You take ln of both sides.
So when you take the ln, you have ln 0.5 equals to ln exponential minus 20k. So we have ln 0.5 equals to minus 20k. So what is k?
Divide both sides by minus 20.
Yes. K is equals to minus 20, 1 over minus 20, ln 0.5. So press this on your calculator, you will have k to be equals to 0.035 minutes. So then our equation, we now go back to the equation, go back to your equation 2. We can now write we can now say the temperature of the bar at any time. Remember, you don't know that time. As a matter of fact, we are not supposed to put minutes here. Remember, K is proportion. It's not time. It's proportion at any time t.
The constant.
Yes, at any time t is then t equals to 100 exponential minus 0.035. See, so equation 4. Now, they can ask, that's the question they asked us to do, but I can go ahead and ask another question on this Roman figure 2. I can ask you, okay, find the time it will take for the bar in the equation 4 to reach temperature of 25 Fahrenheit. Find the time, please write it down. Find the time it will take for the bar in the equation 4 to reach a temperature of 25 degrees Fahrenheit. So how do we solve this? So all you need to do at this point is recall that we have t equals to 100 exponential minus 0.035 t. So which implies 225 equals to 100 exponential minus 0.035 t. So when you divide both sides by what? Yes, anybody?
100.
100. So you have this divided by 100 and this divided by 100. So you have 1 over 4 equals to exponential 0.035t. So you take the ln 1/4, which is the same thing as ln exponential negative 0.35t. So if you solve it very well, you have t equals to 39.6084 minutes. So that is how this question can be, they can ask you. You can look into the textbook and solve as many as possible. Any question, please. For those of us that are here, I hope you are listening.
Yes, sir.
Yes, sir.
Philip, what happened? How are you today?
I'm doing fine, sir. Just that I traveled. I'm in the village and the network is not too good.
I can see.
That is why I'm always on and off like that.
I can see. It is well. Just check and just check with the